Hello students, in this video I will go through exercise U5A01B. Alright, so this exercise focuses primarily on this concept of dilations and what it means to dilate something. So when we're dilating something, we're actually either blowing something up or shrinking it down, all the while keeping the same proportions. Okay, so let's take a look. Question number 6 here. What is the scale factor for the dilation? So the scale factor simply tells us how much bigger or how many times smaller the image is compared to the original. So if I compare, for instance, this pentagon, right, this five-sided shape, I have A, B, C, D, E, and the image A prime, B prime, C prime, D prime, E prime, I notice that all the dimensions here are halved. So therefore the scale factor then is going to be by a factor of 1/2. Alright, so give the coordinates of the dilation. Give the coordinates of the dilation. So in other words, they want us to figure out what exactly is the coordinates of P prime, Q prime, and R prime. So what we do, okay, if the dilation if it doesn't specify over what point, right, it's dilating by a factor of 5, but it doesn't specify over which point to dilate it over, then it is by default over the origin. And if it is over the origin, then all we got to do is just multiply all the coordinates by a factor of 5. So P prime will be 5 comma negative 15. Oops. Q prime will be negative 25, negative 20. R prime will be negative 30. I'm sorry. Will be positive 30 and positive 10. That's all it is. Okay, so here in this case we're not as lucky because here now they're telling us to dilate it by a factor of 3 over point B. So we can't really just multiply the all the coordinates by 3 because we're not dilating over the origin anymore. So what we're going to do is I'm going to draw myself a makeshift graph here. So 0, 4 is going to be like right there, I'm going to say. B is 0, 2, so it's going to be like there. And C is negative 3, comma 2, so of course it's going to be on the other side. So I'm going to erase this and place it over here. So C is negative 3, 2, which is going to be like right there, okay? So if I'm dilating this by a factor of 3, so this guy right here, the length of BC, what is that length? That length is a length of 3. So if I were to dilate this by a factor of 3, then that means C prime, well, B prime will not move because we're dilating over that point. So B prime is still 0, comma 2. C prime, where will that be? Well, since I'm dilating it by a factor of 3, C will stretch out, okay, by a factor of 3, which is going to be 9, right? So that means it's going to be 9, comma, I'm sorry, it's going to be negative 9, comma 2. Okay, and where will A end up? A prime, since A is going to be 2 away from B, I'm going to multiply that by 3. So that means it's going to be 6 away from B, right? So what would that be then? That would be 0, comma 8, because it's 6 away from 0, comma 2. Okay, so there's our coordinates, A, B, and C. And it's okay if we don't list it out in the exact order that they have it, as long as we have the correct coordinates there. Alright, so very similar, we're dilating it by a factor of 4 over point F. Now I have FGHJ. Okay, so I want to draw myself a grid. So F is 0, negative 1. And G is 4 comma negative 1. I'm sorry, I placed it. F is 0, negative 1, so it's over here. And then G is 4, negative 1, so it's going to be like right there. And then H is 4, negative 3. And J is 0, negative 3. Okay, and we're dilating by a factor of 4 over point F. So I'm just going to note the, so G here is 4 comma negative 1, which means F to G, that has a length of 4. G to H, that has a length of 2. And this is 4, and this is 2. Okay? So why is that important? Because when I'm dilating by a factor of 4 over point F, G is going to be no longer 4 away from F, but it's going to be 16 away from F. So G prime is going to be 16 away from F. So what is that? That's going to be 16 comma, and it's going to the y coordinate is going to stay the same. The y coordinate is negative 1. And then H prime. So here we're going to go down 2 and over 4, right? So we're going to, H prime is, we're going to go down 8. Okay, we're going to move down 8 from F. Okay, so that means we're going to go down 8, so that becomes negative 9, and we're going to go over to the right by 16. So it's 16 comma negative 9. And then J prime, okay, we're going to go down 8 from F. Okay, so F was originally at 0, negative 1, so it's going to be 0 comma negative 9. All right. So, and F prime, of course, remains where it was because we're dilating over that point, so it's 0 comma negative 1. Okay. Okay, Kendall was asked to find the scale factor for the dilation. What is Kendall's error? So, looking at this, what is Kendall's error? Oh, and then it says that the scale factor is equal to 3. The scale factor is 3. Well, the thing is, the scale factor is not 3. It's actually 1/3. We always take the image, divide by the original. So the scale factor here is going to be 1/3. Anytime when the scale factor is below 1, it's going to be shrinking. Anytime when the scale factor is above 1, we're going to be blowing up, getting bigger. Okay. Is it always true that dilation of n and dilation of m of x will equal to m times n? Explain. That's an interesting one. So, let's say if we have a coordinate, okay, and this is a comma b. If I dilate a comma b by a factor of n, okay, then the new point, where will it end up? It will end up at a times n, comma b times n, right? That's by a dilation of factor of n. And if I dilate that now by a factor of m, the new point will be amn, bmn. So yes, I agree. This is true. That if I'm dilating first by n of x and then dilate m, this will be equivalent to the dilation of Mn of x. How are the side lengths of the pre-image and dilated image related? So the pre-image and the dilated image. The pre-image is double that of the image, right? So the pre-image, PQRS, if we dilate this by a factor of 1/2, we'll end up with PQRS prime. That's the relationship. Okay. What is the scale factor of the dilation shown? So the dilation looks like to be a factor of 2/3 over point P. And how do I know this? Because this is 3 and this is 2. This right here is 3 radical 2, and then this is 2 radical 2. This guy right here, 2, 1, 3, 2, 4, 5, 2, 4, 6. So this is actually square root of 45, or it's 3 square root of 5, and this is 2 square root of 5. I'm going to make an educated guess. And is that really the case? Let's see here. 2, 4. So 2 squared is 4. Yes, it's square root of 20. So you can see here that all the proportions of sides are going to be 2/3 of the original. Okay, what are the coordinates of 1.5 dilation of 1.5 of ABCD for that? So again, all we got to do is just multiply all the coordinates by 1.5 because we're dilating it over the origin. So 2 times 1.5 is 3. 0 times 1.5 is 0. B prime, 1.5 times 8, so that's 12. Negative 4 times 1.5, that's negative 6. C prime, 1.5 times 4 is 6. 6 times 1.5, negative 6 times 1.5 is negative 9. And D prime of negative 1.5 times negative 5 times 1.5 is negative 7.5. And negative 10 times 1.5 is negative 15. So those are the coordinates. What is the coordinates of a dilation of 2 over a coordinate x, over point x for triangle xyz? So again, there's no real rule here. So what I'm going to do is I mean, there is a rule, but it's more, it's very, very convoluted. If I do write out the rule, it's better to understand this. So 1, 1 is over here. 2, 2 is over here. So this is x, this is y. And z is 3, 0, which is right here. And we're dilating this by a factor of 2. Okay, so y, from x to y, we're going up 1 and over 1, right? So if we multiply by 2 and 2, so y prime, what will that be? It will be 1 plus, I'm going to be moving a distance of 2 up and 2 over. So 2 and 1 plus 2. So it's going to be y prime is 3, 3. And what about z? So z prime, so originally we're at 1, 1, right? So from 1, we're going to go down 1. But since we're dilating by a factor of 2, we're going to go down 2. So we're going to subtract 2. And then Z is horizontally away from X by how much? It is 2 away from X horizontally. So we're going to be moving away from 1, so we're to the right, plus 4. So Z prime will be located at -1, 5. Right. Okay? And if that confused you, you can always draw this thing out like neater. So if I do draw it out neater, this is the situation, right? This is X, 1, 2, 1, 2, 3. So if I blow this by 2, right, this will end up at in this manner, right? So Y prime is at 3, 3, and Z prime is again at -1. I'm sorry, it's at 5, -1. I got it backwards there. 5, -1. So this should be like that. So +4 and -2. So -5. So it's +5, -1. Okay? All right. A figure is dilated using a scale factor of 8 if the area of the image is 832 square units. What is the area of the pre-image? So we're dilating by a factor of 8. The area of the image is 832. So there's a property, okay, that you should have been able to conclude it after having gone through the exercise related to the lesson, okay, is when the scale factor, okay, when we dilate something by a scale factor of k, the perimeter gets multiplied by k. When we dilate by a scale factor of k, the area gets multiplied by k squared. So since the scale factor here is 8, that means we are going to be multiplying the area, which I don't know what the original area was, by a factor of 64. And the new area comes out to be 832. So to get the old area, all I got to do is just divide 832 by 64. And what is that? Let me get the calculator. It's 13 square units. Okay, and moving on, question 22. F prime, G prime, H prime is a dilation of FGH with a scale factor of 3. Okay. What are the values of x and y? So if it's a scale factor of 3, then that means x minus 1 will be 1/3 of y. 2x minus 3 will be 1/3 of 4x plus 3. Right? The original is going to be 1/3 of the image. So I'm going to solve the second equation I just wrote here. I want to multiply both sides by 3 to get 6x minus 9 is equal to 4x plus 3. Add 9 to both sides and subtract 4x. I end up with 2x is equal to 12. Divide by 2, x is equal to 6. So if I know that x is equal to 6, then therefore y will equal to, y will equal to 15. And what is the question asking for? Find what are the values of x and y. So there you go. what are the coordinates of the center of dilation for the dilation shown? So to find the center of dilation, all you got to do is take all the corresponding points, okay, and draw them and connect them together. That's all you got to do. And once you take two corresponding points and connect them together, and they intersect, it's going to be true for all of them. Okay, so because if you look at this for, let's say for this point here, I'm calling P to F, I'm going to go up 1 and over 5, and then up 1 and over 5. Look at that. It just connects. So the point of dilation is located at negative 1 comma 3. So we're dilating this actually by a factor of 2 over negative 1 comma 3 for quadrilateral DEFG. Whoops. And there you go.